Hi, hello there. Welcome to Network Automation. Have you ever set up your home network or a small network? Imagine doing those tasks for tens of thousands of end devices and thousands of routers, switches, and access points. Did you know that there is a software that automates those tasks for an enterprise network? In fact, there is a software that can automate the design of an enterprise network. It can automate all of the monitoring, operations, and maintenance for your network. Interested? Let's get started. So let's start with an automation overview. We now see automation everywhere, from self-serve checkout at stores and automatic building environmental controls to autonomous cars and planes. So how many automated systems do you encounter in a single day? There is an increase in automation. So automation is any process that is self-driven, that reduces and potentially eliminates the need for human intervention. So automation was once confined to the manufacturing industry. Highly repetitive tasks such as automobile assembly. So were turned over to machines and the modern assembly line was born. So machines excel at the repeating same tasks without fatigue and without the errors that humans are prone to make in such jobs. So these are some of the benefits of automation. Okay, so machines can work 24 hours a day without breaks, which results in a greater output. Machines provide a more uniform product. Automation allows the collection of vast amounts of data that can be quickly analyzed to provide information which can help guide an event or a process. So robots are used in dangerous conditions such as mining, firefighting, and cleaning up industrial accidents. This reduces the risk to humans. And the last one is, under certain circumstances, smart devices can alter their behavior to reduce energy usage, make a medical diagnosis, and improve automobile driving safety. Next would be thinking devices. Have you heard about it? Well, can devices think? Can they learn from their environment? In this context, there are many definitions of the word think. One possible definition is the ability to connect a series of related pieces of information together and then use them to alter the course of action. So many devices now incorporate smart technology to help them govern the behavior. This can be as simple as smart appliance lowering its power consumption during periods of peak demand or as complex as self-driving car. So whenever a device takes a course of action based on an outside piece of information, then that device can refer to as a smart device. Many devices that we interact with now have the word smart in their names. Okay? So this indicates that the device has the ability to alter its behavior depending on its environment. So in order for these devices to think, they need to be programmed using network automation tools. Okay, so the concepts of data formats. Okay, so smart devices are in fact tiny computers. So for smart device such as an actuator to react to changing conditions, it must be able to receive and interpret information sent to it by another smart devices, such as sensor. These two smart devices must share a common language, which is called the data format. Shared data formats are also used by other devices in the network. So the data format concept, when sharing data with people, the possibilities of how to display that information are almost endless. For example, think of how a restaurant might format their menu. It could be in text only, a bulleted list, a photos with captions, or just a photos, right? So these are all different ways in which a restaurant can format the data that makes up their menu. So a well-designed form is dictated by what makes the information the easiest for the intended audience to understand. This same principle applies to shared data between computers. A computer must put the data into a format that another computer can understand. So data formats are simply a way to store and exchange data in a structured format. One such format is called Hypertext Markup Language, or the HTML. Alright? So HTML is a standard markup language for describing the structure of web pages as shown here in the figure. So basically, if you are given this HTML tags, okay, so the output of this HTML tag is given on the right side, okay? So if you'll observe, we have here the code, and this is the output in the forms. All right? Okay, so there are some common data formats that are used in many applications, including network automation and programmability. So this includes these languages, JavaScript, object notation, or popularly known as the JSON, extensible markup language, or XML, and you've got the YAML. It ain't a markup language, right? YAML ain't markup language, right? So the data format that is selected will depend on the format that is used by the application, tool, or script that you are using. So many systems will be able to support more than one data format, which allows the user to choose their preferred one. Let's talk about data format rules now. So data format have rules and structure similar to that we have with programming and written languages. So each data format will have a specific characteristics. Okay? So first, there is a syntax, which includes the types of brackets used, such as the symbol here, okay, open and close bracket. You've got parentheses and you've got braces. So the use of white space or indentation, quotes, commas, and more is part of a syntax. Next, how objects are represented, such as characters, strings, lists, and arrays. How key or value pairs are represented. The key is usually on the left side and it identifies or describes the data. The data on the right side, okay, is the data itself and can be a character, string, number, list, or another type of data. So search the internet for Open Notify ISS location now to find a website that tracks the current location of the International Space Station. At this website, you see how data formats are used and some of the similarities between them. So this website includes a link for a simple application programming interface or API called to a server, which returns the current latitude and longitude of the space station along with a Unix timestamp. So the following example shows the information returned by the server using a JavaScript object notation or JSON. The information is displayed in a raw format. This can make it difficult to understand the structure of the data. Alright, so next is you search the internet to find the JSON view, okay, browser extension or any extension that will allow you to view JSON in more readable format. So data objects are displayed in key or value pairs. The following output shows the same output using JSON view. So the key value pairs, which are much easier to interpret. In the example below, you can see the latitude and its value at 25.99990. Okay? So note that JSON view may remove the quotation marks from the key quotation marks are required when coding JSON key or value pairs. It's shown here, JSON format. Okay? So to see this same formatted as SAML and YAML, search the internet for JSON conversion tool. So at this point, it is not important to understand the details of each data format, but notice how each data format make use of syntax and how the key or value pairs are represented. Right? So we have here 3 different formats which gives the same output. Okay, so how about the JSON data format? So JSON is a human readable data format used by application for storing, transferring, and reading data. JSON is a very popular format used by web services and APIs to provide public data. This is because it is easy to parse and can be used with most modern programming languages, including Python. Okay, so the following output shows an example of the partial iOS output from the show interface Giga Ethernet 0/0/0 command on a router. Okay, now this same information can be represented in JSON format. So notice that each object, each key value pair is different piece of data about interface, including its name, a description, and whether the interface is enabled. Okay, so next is the JSON syntax rules. So there are some of the characteristics of JSON. Okay, so it is hierarchical structure and contains nested values. It uses braces to hold objects and square brackets to hold an array. And its data is written as key or value pairs. So in JSON, the data known as an object is one or more key value pairs in close braces. The syntax for JSON objects includes keys must be strings within a double quotation marks. Okay? So values must be a valid JSON data format like string type, number type, array, boolean, null, or another object. Keys and values are separated by a colon. So multiple key or value pairs within an object are separated by commas. So white space is not significant. Okay? So at times, a key may contain more than one value. This is known as an array. Okay? So an array in JSON is an ordered list of values. Characteristics of an array in JSON includes the key followed by a colon and a list of values enclosed in square brackets. So the array is an ordered list of values. The array can contain multiple values, including a string, number, boolean, object, or another array inside the array. So each value in the array is separated by a comma. So for example, a list of IP addresses might look like the following output. So the key is address. So each item in the list is separated by braces, okay, or curly braces, right? So the array of the objects in the list is also separated by a comma following the enclosing or the closing bracket for each of the type. Okay? So you've got the IP here, comma, and then followed by the net mask or the network mask. Okay, so next is YAML. Okay, So YAML or YAML is another type of human readable data format used by applications for storing, transferring, and reading data. Some of the characteristics of YAML includes the following. So it is like JSON and is considered a superset of JSON. It has a minimalist format, making it easy to both read and write. It uses indentation to define its structure without the use of brackets and commas. Okay? So for example, look at this JSON output for a gigabit Ethernet 2 interface. Okay? So this one is a JSON for gigabit Ethernet 2. Okay? Now, the same output in YAML format is easier to read, similar to JSON. So a YAML object is one or more key value pairs. So each value pairs are separated by a colon without the use of a quotation mark. So in YAML, a hyphen is used to separate each element in the list. So this is shown for the three IPv4 addresses in the following output. Okay, so you've got the YAML for gigabit Ethernet 2 on this representation here. Okay, so they have the same output but different data representation. So one is in JSON and the other one is in YAML. Okay, so how about the XML or the SAML data format? SAML is one type of human readable data format used to store, transfer, read data by applications. Some of the characteristics of SAML includes the following. So it is like an HTML, okay? So which is the standardized markup language for creating web pages and web applications. It is self-descriptive, okay? So it encloses data within a related set of tags. And unlike HTML, SAML uses no predefined tags or document structure. So SAML objects are one or more key value pairs with the beginning tag used as the name of the key. Okay, so key value and then the ending tag key. So the following output shows the same data for gigabit Ethernet 2 formatted as a SAML data structure. This is the same output presented earlier. So notice how the data are enclosed within the object tags. In this example, okay, so each key value pair is on a separate line and some lines are indented. Okay, so this is not required but is done for readability. The list uses a repeated instances of tag. Okay, you've got the starting tag and the ending tag for each element in the list. The elements within these repeated instances represent one or more key value pairs. So try to evaluate and compare the SAML output for gigabit Ethernet 2. All right. Okay, so the next section is the APIs. So maybe you often heard the word API. So what is this for? Okay. So let's talk about the API concept. Data formats shared between smart devices often use an application programming interface or API. So as you will learn in this topic, an API is a software that allows other applications to access its data or services. So API is found almost everywhere. Okay, so Amazon Web Services or AWS, Facebook, and home automation devices such as thermostats, refrigerators, and wireless lighting systems all use an APIs. They are also used in building programmable network automation. So an API is a software that allows other applications to access its data or services. It is a set of rules describing how one application can interact with another, and the instructions to allow the interaction to occur. The user sends an API request to the server asking for specific information and receives an API response in return from the server along with the requested information. Okay? So an API is similar to a waiter in a restaurant, as shown in the following diagram here. A customer in a restaurant would like to have some food delivered on the table. Okay? So therefore, the customer will be doing a request. Alright? So the food is in the kitchen where it is cooked and prepared. So the waiter is the messenger, similar to an API. So the waiter or the API in this example or in this diagram is the person who takes the customer's order or request and tells the kitchen what to do. Right? So it's sort of the mediator, okay, between the user and the application. Now in this example, between the customer and the kitchen or food servers, or the kitchen or food chef, right? Next, so when the food is ready, the waiter will then deliver the food. That is now the response back to the customer. Okay, so previously you saw an API request to server which returned the current latitude and longitude of the International Space Station. So this was an API that Open Notifies provides to access data from a web browser at the National Aeronautics and Space Administration, or NASA. Okay, so to really understand how APIs can be used to provide data and services, we will look on the two options for booking airline reservations. All right, so the first option uses the website for a specific airline. Okay, now using the airline's website, the user enters the information to make a reservation request. The website interacts with the user directly with the airline's own database and provides the user with information matching the user's request. Okay? Now, instead of using an individual airline website, which has a direct access to its own information, there is a second option. Users can use a travel site to access the same information, not only from the specific airline, but a variety of airlines. In this case, the user enters in similar reservation information. The travel service website interacts with the various airline databases using APIs provided by each airline. Now, the travel service uses each airline API to request information from the specific airline. And then, it displays the information from all the airlines on each web page as shown in the diagram here. Okay, so we have several airlines connected to this travel service. Okay, so the API acts as a kind of messenger between the requesting application and the application on the server that provides data or service. The message from the requesting application to the server where the data resides is known as an API call. All right, so this is an API calls here. Okay, so an important consideration when considering or when developing an API is the distinction between open, internal, and partner APIs. Okay, so when you say open APIs or public APIs, these APIs are publicly available and can be used with no restrictions. So the International Space Station API is an example of a public API. Because these APIs are public, many API providers such as Google Maps, okay, so require the user to get a free key or token prior to using the API. So this is to help control the number of APIs requests they receive and process. So search the internet for a list of public APIs. Okay, so the next one is internal or private APIs. So these are APIs that are used by an organization or company to access data and services for internal use only. So an example of an internal API is the following, or is allowing authorized salesperson access to internal sales data on their mobile devices. And the last one is partner APIs. So these are APIs that are used between a company and its business partners or contractors to facilitate business between them. The business partners must have a license or other form of permission to use the API. So a travel service using an airline's API is an example of a partner's API. All right? Okay. So there are several types of web service APIs. Okay? So a web service API is a service that is available over the internet using the World Wide Web. So there are 4 types of web service API. So these are the Simple Object Access Protocol, or SOAP. Okay? SOAP is a messaging protocol for exchanging SAML structured information, most often over the HTTP or SMTP. Okay? So also, you've got the REST, all right, or the representational state transfer. Next is the SAML RPC, or the extensible markup language remote procedure call, and the JavaScript object notation, or the JSON RPC, or the remote procedure call. Okay? So, SOAP is designed by Microsoft in 1998. So, SOAP APIs are considered slow to parse, complex, and rigid. So this leads to the development of a simpler REST API framework, which does not require a SAML. So REST uses HTTP, less verbose, and is easier to use than SOAP. So REST offers or refers to a style of software architecture and has become popular due to its performance, scalability, simplicity, and reliability. So REST is the most widely used web service API, accounting for over 80% of all the API types used. So REST will be further discussed in this module. So RPC, or the remote procedure calls, is when one system requests that another system execute some code and returns the information. So this is done without having to understand the details of the network. So this works much like REST API, but there are differences dealing with formatting and flexibility. So the SAML RPC is a protocol developed prior to SOAP. The later evolved into what became a SOAP. JSON RPC is very simple protocol and similar to SAML RPC. All right? Okay, so let's discuss details on REST. Okay, so you've got REST and RESTful API. So web browsers uses HTTP or HTTPS to request using the GET, okay, a web page. If successfully requested, HTTP status code 200, web servers respond to GET requests with an HTML coded web page. So simply stated, a REST API is an API that works on top of the HTTP protocol. It defines a set of functions developers can use to perform requests and receive responses via HTTP protocols such as GET or POST. Okay? Now, conforming to the constraints of the REST architecture, it is generally referred to as being RESTful. An API can be considered RESTful if it has the following features. Okay? So there is a client server. The client handles the front end and the server handles the back end. Either can be replaced independently of the other. Next, it should be stateless. No client data is stored on the server between requests. The session state is stored on the client, right? And it should be cacheable. So clients can cache responses to improve performance. Okay? So web browsers use HTTPS, okay, to request or get data from a web page, as shown in this diagram here. Okay, so REST is an architectural style for designing web service application. Okay, so it refers to a style of web architecture that has many underlying characteristics and governs the behavior of clients and servers. So simply stated, a REST API is an API that works on top of the HTTP protocol, right? So it defines a set of functions developers can use to perform requests and receive responses via HTTP, right? Such as GET and POST protocols, similar to that of HTML, or which is being used also in HTML. Now, conforming to the constraints of the REST architecture is generally referred to as being RESTful. An API can be considered RESTful if it has the following features as stated earlier. Now, let's talk about the RESTful implementation. So a RESTful web service is implemented using HTTP. It is a collection of resources with 4 defined aspects. So the base uniform resource identifier or URI for the web service, such as http://example.com/resources. The data format supported by the web service. This is often a JSON, YAML, or SAML, but could be any other data format that is valid hypertext standard. The setup operation supported by the web service using HTTP methods. And the API must be hypertext driven. So RESTful APIs use common HTTP methods including POST, GET, PUT, PATCH, and DELETE, as shown in the following table. This corresponds to RESTful operations: create, read, update, and delete, or CRUD. Okay, so again, this is the HTTP comparison with the RESTful operation. Now, in the figure, the HTTP request asks for JSON format data. So if the request is successfully constructed according to the API documentation, the server will respond with JSON data. This JSON data can be used by a client's web application to display the data. For example, a smartphone mapping app showed the location of the San Jose, California. Okay, so that would be shown. Okay, so how about the URI, URN, and URL? Okay, so web resources and web services such as RESTful APIs are defined using the URI. Okay, a URI is a string of characters that identifies specific network resource. Okay, so it has 2 specializations, right? So first is the URN. URN, or the Uniform Resource Name, identifies only the namespace of the resource, web page, document, image, etc., without reference to the protocol. The next one is the Uniform Resource Locator, or the URL. Okay, it defines the network location of a specific resource on the network. So HTTP or HTTPS URLs are typically used with web browsers. Other protocols such as FTP, SFTP, SSH, and others can use a URL. A URL using SFTP might look like this format. Okay, so SFTP, you've got ://sftp.example.com. All right. Next, these are the parts of the URI as shown in the figure. You've got the protocol scheme, HTTPS or other protocols such as FTP, SFTP, Mail2, and NNTP. You've got the host name, which is the example.com here. All right. You've got the path and the file name, which includes the author, okay, /author/book.html. And you've got the fragments, #page155. Okay. So these are the parts of the URI. Now, in a RESTful web service, a request made to a resource URI will elicit a response. The response will be a payload typically formatted in JSON, but could be HTML, SAML, or some other format. Now, the figure here shows the URI, okay, for the MapQuest Directions API. So the API request is for directions from San Jose, California to Monterey in California. So this is how it looked like. We've got from San Jose, California, and to Monterey, California. Now, these are the different parts of the API request. Okay, so you've got the API server. This is the URL for the server that answers REST requests. In this example, it is the MapQuest API server. Next is the resources. Resources specifies the API that is being requested. In this example, it is the MapQuest Directions API. You also have query, specifies the data format and information the client is requesting from the API service. So queries can include format, right? So this is usually JSON, but can be YAML or SAML. So in this example, JSON is requested. You also have key. The key is for authorization. If required, MapQuest requires a key for their Directions API. In the above URI, you would need to replace the key with a valid key to submit a valid request. Okay? And then the last one is the parameters. Parameters are used to send information pertaining to the request. In this example, the query parameters include information about the directions so that the API needs, so it knows the direction to return. That is from San Jose, CA. Okay? That is from San Jose, CA and to Monterey, CA. Alright? Now, many RESTful APIs, including the public APIs, requires a key. The key is used to identify the source of the request. So here are some of the reasons why an API provider may require a key. Okay? So first, to authenticate the source to make sure they are authorized to use the API. Second is to limit the number of people using the API. Next, to limit the number of requests per user, and to better capture and track data using the requested by the browser or users. Okay? And to gather information on the people using the API. So note that if you wish to use the MapQuest API, the API does not require a key. Search the internet for the URL to obtain the MapQuest key. So use the search parameters developer.mapquest. You can also search the internet for the current URL that outlines the MapQuest privacy policy. Okay, so how about RESTful API applications? So many websites and applications use API to access information and provide service to their customers. For example, when using a travel service website, the travel service uses the API of various airlines to provide the user with airline, hotel, and other information. Okay? So some RESTful API requests can be made by typing in the URL from within the web browser. So the MapQuest Directions API is an example of this. So a RESTful API request can also be made in other ways. Right? So we have several ways of doing it. Okay, so developers' website. Developers often maintain websites that include information about the API, parameter information, and usage examples. Okay, So these sites may also allow the user to perform the API request within the developer web page, or by entering in the parameters and other information. So the following figure here shows an example of the MapQuest Directions API web page. Okay, so it's a MapQuest developer site. Next is the Postman. Okay, so Postman is an application for testing and using the REST APIs. It is available as a browser app or standalone install. So it contains everything required for constructing and sending REST API requests, including entering query parameters and keys. Postman allows you to connect or to collect and save frequently used API calls in history, or as query parameters and keys. So Postman allows you to collect and save frequently used API calls in history, okay, or as collections. Postman is an excellent tool for learning how to construct API requests and for analyzing the data that is returned from the API. So the following figure here shows an example of using the MapQuest API with Postman. Okay, next is the programming language Python. So APIs can also be used within a Python program. So this allows for possible automation, customization, and app integration of the API. So the following figure here shows an example of part of Python program used to submit a request to the MapQuest API. Right? And the last one is the network operating systems. So using protocols such as netconf or net configuration and restconf, okay, REST configuration, the network operating systems are beginning to provide an alternative method for configuration, monitoring, and management. For example, the following output might be the opening response from a router after the user has established a netconf session at the command line. However, working at the command line is not automating the network. Instead, a network administrator can use Python scripts or other automation tools like the Cisco DNA Center to programmatically interact with the router. Okay, so next would be the configuration management tools. So as mentioned in the introduction of this module, setting up a network can be very time consuming. Configuration management tools can help you to automate the configuration of routers, switches, firewalls, and many other aspects of your network. So the traditional network configuration, network devices such as routers, switches, and firewalls have traditionally been configured by a network administrator using CLI. That's what we do at the lab, right? So whenever there is a change of a feature or a new feature, okay, so the necessary configuration commands must be manually entered on all the appropriate devices. So in many cases, this is not only time consuming, but can also be prone to errors. So this becomes a major issue on a larger networks with more complex configurations, right? So traditionally, we are using CLI to configure these devices. Okay. Next, the Simple Network Management Protocol or SNMP. This was developed to allow administrators to manage nodes such as servers, workstations, routers, switches, and security appliances on an IP network. So using a network management station or NMS, okay, as shown in the following figure here, right? So SNMP enables network administrator to monitor and manage network performance, find and solve network problems, and perform queries for statistics. So SNMP works reasonably well for device monitoring. However, it is not typically used for configuration due to security concerns and difficulty in implementation. Although SNMP is widely available, it cannot serve as an automation tool for today's network. So you can also use APIs to automate the development and deployment and management of network resources. So instead of the network administrators manually configuring ports, access lists, quality of service or QoS, and load balancing policies, they can use tools to automate configurations. So these tools look into a network APIs to automate the routine network provisioning tasks, enabling the administrator to select and deploy network services they need. So this can significantly reduce many repetitive and mundane tasks to free up time for network administrators to work on more important things. Okay? So with network automation, we are rapidly moving away from the world where network administrators or systems administrator manages a few dozen network devices to one where they are deploying and managing hundreds or thousands or even tens of thousands of complex network devices, both physical and virtual, with the help of software. This transformation is quickly spreading from its beginning in the data center, okay, to all the places in the network. So there are new and different methods for network operators to automatically monitor, manage, and configure the network. So as shown in the figure, okay, so this includes protocols and technologies such as REST, Ansible, Puppet, Chef, Python, JSON, SAML, and more. So configuration management tools like the RESTful API requests to automate tasks and can scale across thousands of devices. So configuration management tools maintain the characteristics of a system or network for consistency. There are some characteristics of the network that administrators benefit from automating. Okay, so these are the software and version control, device attributes such as names, addressing, and security. You've got protocol configurations and the ACL configurations. So configuration management tools typically include automation and orchestration. So automation is where a tool automatically performs a task on a system. This might be configuring an interface or deploying a VLAN. So orchestration is the process of how all these automated activities need to happen, such as the order in which they must be done, what must be completed before another task is begun. Okay? So orchestration is the arranging of the automated tasks that results in a coordinated process or workflow. Okay? So you have that two important term here, right? You've got orchestration and automation. Okay? So as mentioned earlier, so there are several tools available to make the configuration management easier. So you've got this Ansible, Puppet Labs, Chef, and the SaltStack. Okay? So the goal of these tools is to reduce the complexity and time involved in configuring and maintaining a large-scale network infrastructure with hundreds or even thousands of devices. Okay? So these same tools can benefit smaller networks as well. Now, comparing Ansible, Chef, Puppet, and SaltStack. Okay, so Ansible, Chef, Puppet, and SaltStack all come with API documentations for configuring RESTful APIs requests. So all of them can support JSON and YAML as well as other data formats. So the following table shows a summary of the comparison of major characteristics of Ansible, Puppet, Chef, and SaltStack configuration management tool. Okay, so characteristics. So what programming language? So Ansible, SaltStack are both built on Python. Okay, whereas Puppet and Chef are built on Ruby. Okay, so similar to Python, Ruby is an open source programming language that is cross-platform. However, Ruby is typically considered a more difficult language to learn than Python. Okay? Next is the agent-based or agentless. So configuration management is either agent-based or agentless. So agent-based configuration management is pull-based, meaning the agent on the managed device periodically connects to the master for each configuration information. So changes are done on the master and pulled down and executed by the device. So agentless configuration management is push-based. A configuration script is run on the master. The master connects to the device and executes the tasks in the script. So of the 4 configuration tools in the table, only Ansible is agentless. All right. Next, how are devices managed? So this lies with a device called master in Puppet, Chef, and SaltStack. However, because Ansible is agentless, any computer can be a controller. All right. And the last one is what is created by the tool. So network administrators use configuration management tools to create a set of instructions to be executed. So each tool has its own name for these instructions. So playbook, cookbook, manifest, and pillar. So common to each of these is the specification of policy or configuration that is to be applied to devices. So each device might have its own policy. For example, all Linux servers might get the same basic configuration and security policy. Okay? Now let's talk about the IBN and the Cisco DNA Center. So you have learned, okay, of the many tools and software that can help you automate your network. The intent-based networking or IBN and the Cisco Digital Network Architecture or DNA Center can help you bring it all together to create an automated network. Okay, so IBN or the intent-based networking is the emerging industry model for the next generation of networking. So IBN builds a software-defined networking or SDN, transforming a hardware-centric and manual approach to designing and operating networks to one that is software-centric and fully automated. So business objectives for the network are expressed as intent. All right. So IBN captures business intent and uses analytics, okay, machine learning, and automation to align the network continuously and dynamically as business needs change. So IBN captures and translates business intent into network policies that can automate and applied consistently across the network. Okay, so Cisco views IBN as having 3 essential functions. You've got translation, okay, activation, and assurance. So this function interact with the underlying physical and virtual infrastructure as shown in the figure. Okay, so translation, when you say translation, the translation function enables the network administrator to express the expected networking behavior that will best support the business intent. So next is activation. Activation, the captured intent then needs to be interpreted into policies that can be applied across the network. The activation function installs these policies into a physical and virtual network infrastructure using the network-wide automation. Next is assurance. In order to continuously check that the expressed intent is honored by the network at any point in time, so the assurance function maintains a continuous validation and verification loop. Okay? So how about network infrastructure as a fabric? Okay? So from the perspective of the IBN, The physical and virtual network infrastructure is a fabric. Fabric is a term used to describe an overlay that represents the logical topology used to virtually connect to devices, as shown in the figure here. Okay, so the red broken lines represents an overlay control plane. Okay, so the overlay limits the number of devices the network administrator must program. It also provides services and alternative forwarding methods not controlled by the underlying physical devices. For example, the overlay is where the encapsulation protocols like IP, okay, or IPsec, okay, and control and provisioning of wireless access points (CAPWAP) occur. So using an IBN solution, the network administrator can specify through policies exactly what happens in the overlay control plane. So notice that how the switches are physically connected is not a concern of the overlay. Okay? Now, the underlay network is the physical topology that includes all the hardware required to meet the business objectives. The underlay reveals additional devices and specifies how these devices are connected. So as shown in the figure, okay, so endpoints such as servers in the figure access the network through a layer 2 devices. The underlay control plane is responsible for simple forwarding tasks. Okay, so when you say underlay network, that is still the traditional networks that we have. All right. Next is the Cisco Digital Network Architecture, or the Cisco DNA. Now, Cisco implemented the IBN fabric using the Cisco DNA. Okay, the business intent is securely deployed into a network infrastructure, or they call it the fabric. The Cisco DNA then continuously gathers data from a multitude of sources, devices, and applications to provide a rich content of information. This information can then be analyzed to make sure that the network is performing securely at its optimal level and in accordance with the business intent or objective and network policies. Okay? Now, the Cisco DNA is a system that is constantly learning, adapting to support the business intent or the business needs. Now, the table lists some of the Cisco DNA products and solutions. Okay? So, this SD Access and SD1 is a topic on fabric technologies on CCNP, right? And it's very promising. Okay? So you also have this Cisco DNA Assurance and Cisco DNA Security. Now, these solutions are not mutually exclusive. For example, all 4 solutions could be deployed by an organization. Many of the solutions are implemented using the Cisco DNA Center, which provides a software dashboard for managing an enterprise network. Okay? So the Cisco DNA Center is a foundational controller and analytics platform at the heart of the Cisco DNA. It supports the expression of intent for multiple use cases, including basic automation capabilities, fabric provisioning, and public-based segmentation in the enterprise network. So Cisco DNA Center is a network management and command center for provisioning and configuring network devices. It is a hardware and software platform providing a single pane of glass or single interface that focuses on assurance, analytics, and automation. The DNA Center interface launch page gives you an overall health, okay, or the summary and network snapshot, as shown in the figure. So from here, the network administrator can quickly drill down into areas of interest. Okay, so at the top, menus provides you access to DNA Center's 5 main areas, as shown in the figure. So these are the design, policy, provision, assurance, and platform. So design, model your entire network. So from sites and buildings to devices and links, both physical and virtual, across campus, branch 1, and cloud. For policy, Use policies to automate and simplify network management, reducing cost and risks while speeding rollout on new and enhanced services. Provisioning is provide new service to users with ease, speed, and security across the enterprise network, regardless of the network size and complexity. Assurance pertains to use of proactive monitoring and insights from the network, devices and applications to predict problems faster and ensure that the policy and configuration changes achieve the business intent and the user experience you want. And the last one is the platform. Use APIs to integrate with your preferred IT systems to create end-to-end solutions and add support for multi-vendor services. All right. So we come to an end of this video lecture, and we have presented a brand new networking. All right. So in the future, everything will be in the software-defined networking. Okay, and we will be using this fabric technologies. Okay, and intelligently controlling and configuring or monitoring the network infrastructure. Okay, so that ends up this video presentation. Have a great day. Thank you for watching.